Alright, so this is video 1 for week 2. Alright, we're going to be learning about different types of transformations, things that we can do to an object. We're going to be transforming them. Alright, we're going to be looking at reflections and translations. That's what our goal is for this video. If by the end of this video you feel confident with reflections and translations, you are good. If not, re-watch this video. Alright, next slide. So our video notes for today, we're going to start off with reviewing how to graph points, because you need to know how to graph points and identify points, so the coordinates, before we start these transformations, the 2 transformations we're going to learn today. Alright, so we'll do 3 examples of translations. We'll have a little mind break, and then we will have 3 examples of reflections. Transformations. There are 4 types of transformations we are going to be learning this week. Alright, so this is for the first lesson. This is for the second lesson, so the second video. And this is the third lesson. Alright, so for this first video, we're going to be looking at translations and reflections. For the second video, dilations. And for the fourth video, rotations. These are the 4 different types of transformations, things we can do with an object or coordinates. You'll see. Next slide. So you might want to have grid paper that will help you. If you do not have grid paper, you could just look off of this paper and just write your coordinates here. That will help out a lot, so that you don't have to draw this whole coordinate plane. I'm not expecting you to draw it. If you have this part and you're identifying them, that works. All right, and then taking some notes if you need to, on anything else that I may say or that we may do on this slide. So go ahead and pause this when I'm done talking and practice these, meaning write in the coordinates. Like this one is A. I need to find A. Here's A. What's that coordinate for this one? So go ahead and pause it and complete A through M, and then come back so that we can go over it. Go ahead and pause now. Welcome back. So if I'm trying to find the coordinate for A, here's point A. When you are finding the coordinate or plotting a point, you always start at the origin. This is the origin right in the middle. Alright, then you go left to right on the x-axis. So the x always comes first and then the y. Okay, so you go left or right depending which direction you're going. Here, these are the positive numbers. Here, these are the negative numbers. So I know it's going to be to the right because A is on this side. So I'm going to go 4 over. So my x is 4. And then I'm going to go up 1, 2, 3, 4. So that coordinate is 4, 4. For B, here's B over here. Start at the origin. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be negative 9 on the x-axis. This is the x-axis. This is the y-axis. Then I need to go up 1, 2, 3, 4, 5, 6, 7. There we go. So it's going to be negative 9, 7 to get to B. C is negative 7, negative 4. Start at 0. Always go on the x-axis first. Negative 7. And then it's negative 4. I go down 4, so negative 4. D, start at the origin, go to 9, up 2, so it's 9, 2. E, and negative 3, 2. F, where is F? F is over here. Start at the origin, over 7, down 3. So 7, down 3, so negative 3. G, negative 2, negative 5. Negative 2, negative 5. So left 2, down 5. So if you're going left or down, that's negative. Alright, so left or down, that's negative. If you're going up or to the right, that's positive. H. Find H. H is right here. So I'm going to go negative 4, 3. For I, where is I? I is way over here. So this is 10. This will be 11. 11, negative 7. So 11, 11, negative 7. For J, J's right here. So it'll be, I don't go anywhere because it's straight up. So it's going to be 0, 5. Okay. Oh, I'm going to go negative 9, but I don't go up or down. It's right on the x-axis, so it's going to be negative 9, 0. Because I don't go up or down on the y, so it's at 0. L. L is right here. That's 0, negative 3. And M. M is right here. That's going to be 3, 0. So if you are having trouble with finding these coordinates, these are coordinates. If you're having trouble finding them, you should practice that. Or you should know how to do this. It's going to help you with everything that we are doing for this week. All right, next slide. Transformations. It is what you do to a 2D figure. So a figure that I may give you, you can translate it, you can reflect it, you can dilate it, and you can rotate it. Translate is like a slide. You slide the image over. Reflect it is like a flip. You flip the image. Dilate is you change the size, so you make it bigger or smaller. Rotate it, well, makes sense, right? You rotate it. Alright, so you turn it. The points stay the same distance apart and lines stay at the same angle after they have been rotated, reflected, and or translated. What this is saying is, if you rotate an image, if you reflect it, or if you translate it, the image will be the same image. It's just turned, flipped, or slid to the side. It does not change the shape or size of it, so it doesn't get bigger or smaller. That only happens with the dilation. Okay, so if you dilate a figure, then you change its size. That's the only one that changes its size. If you reflect it, rotate it, or slide it over, then it's the same exact image. All right, it doesn't get bigger or smaller. It doesn't. Only for the dilation, and that's what we're going to see for the next lesson. So with these images that we're going to be looking at today, and for the rotation, which will be on the third lesson, right, the lengths and angles stay the same. They don't change. For example, if I have this image and I know this is 90 degrees, if I were to slide it, if I were to go up 3 on the coordinate plane and then to the right 5, it would be the same exact image and it will still be 90 degrees in that corner. Nothing happens to it. It doesn't change its size. The numbers don't change. The only time that happens is when you dilate it. And that's not what we're doing today. So dilations, just like what I've been saying, change the size and the shape. All right, because it does that, it's now called similar. All right, so meaning if I have a little heart and then I make it bigger, these two are not equal to each other. They are similar. Okay, they're similar. And the symbol for similar is this. It kind of looks like the approximation symbol. The approximation has two of these. All right, but for similar, it just has one squiggly line. So they don't equal each other when you dilate. But no matter what you do, angles always stay the same. Even if you dilate it, the angles always stay the same. So if I have this little rectangle and I know that's 90, if I make it bigger, pretend it's a perfect rectangle, if I make that rectangle bigger, this will still stay 90 degrees. The only thing that changes with a dilation are the lengths of the sides. So the only thing that changes the lengths, the measurements of an image are dilations. All right, again, we're going to be seeing that later, but I wanted to present this to you all on one slide so that you can see where we're headed. All right, next slide. All right, so on this slide, we're just going to practice labeling quadrants, axes, and the origin. We talked about last time on the other slide that this is the origin, and it's at 0, 0. Quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. I want to review this because later we're going to use this to help us. I think it's in the 3rd lesson. Okay, so quadrant 1, quadrant 2, quadrant 3, quadrant 4. All right, if you want to know the signs, this is what it is. It's positive x values and positive y values. Make that look like a positive. Over here represents negative x values and positive y values. Here it's negative x's and negative y's. Here it is positive x's and negative y's. And this is the x-axis and this is the y-axis. So please make sure that you remember this and are familiar and comfortable with it. All right, next slide. Translations. So let's start off with translations. Remember, there are two transformations that we are learning today: translations and reflections. We're going to start off with translations. If we translate an object, we move it up or down or side to side. But again, we do not change its shape, size, or direction. So we are not changing the shape. We are not changing the size. To change the size, that's a dilation. And we're not changing the direction. If we're changing the direction, that's a rotation. When we move a shape, it gets a new name. If the point is A, the original point is A, and I move it in whatever way, I do a transformation to it, it gets a new name that's called A prime. And it looks like this, all right? So it looks like A with a little tally mark on it. Okay, there's a possibility of doing a transformation and then doing another transformation to it. And when I do that, I will label it as that. And then so on. That would be a double prime, a triple prime, and it keeps going. All right, next slide. So this is just an example to kind of show you what's really going on, and it reinforces the definition of dilation, reflection, rotation, and translation. The question says, which of the following triangles, P, Q, or R, is a translation of triangle ABC? Well, here's triangle ABC, A, B, C. It says, which one is a translation? Well, I know that for the transformations, there's something where I flip it, there's something where I slide it, there's something where I turn it, and there's something where I change the size. I wonder what's going on here. Alright, so if this is my original image right here, which one looks like I just slid it over somewhere? Well, this one looks like I flipped it. Okay, so if this is a flip, do you remember what flip represents? That's a reflection. Oh, that looks horrible. Reflection. Okay, that's a reflection. Let's look at this one. How did it get from here to here? Well, it looks like it got bigger. Do you see the thickness from here to here compared from here to here? It got bigger. The size changed. Do you remember what that one is called? Dilation. This one is the same exact shape. We just slid it over. That is our translation. So that's the one we want. Okay. All right, next slide. So here is more of an example of something like what we're going to be doing. It says triangle PQR. So here it is, PQR. Oh, that looks bad. PQR needs to be translated 3 units down and 4 units to the right. This is exactly what you are going to be doing. So let me fix this because I made that look bad. Oops, I'm still on the eraser. So here's my image. This is what you're going to be doing for a translation if I give you the image. These are coordinates. You're going to be looking at the vertices of each shape. And that's what you're going to be using to help you reflect and translate for today. So it says triangle PQR needs to be translated 3 units down and 4 units to the right. So that means each point you're going to go 3 down and 4 to the right. 1, 2, 3, 4. And when you're working on the coordinate plane, it will look a lot better. And remember, here's my original point, Q. But when I move it to its new position, after I do my transformation, and in this case I'm doing a translation, it turns into Q prime. That's why it has a little 1 in front of it, on top of it. Okay. And now I do it for the next point. So down 3 over 4. 1, 2, 3, 4. And now this one is called P prime. This one was Q prime. Now let me do it for the next one. Down 3. It's the same thing for each point, each vertice. And then over 4. 1, 2, 3, 4. And that becomes R prime. At this point, it turns into one of my favorite games, connect the dots. Okay, now you have your translated figure, which is right here. So you're going to look at the vertices. Each vertex needs to be moved 3 units down and 4 units to the right. So all of these vertices have been translated in the same way. That's what we want. And the image and the object and its image are exactly the same size and shape. So basically, this can be called the pre-image, which is the original. Right? And then this is the new image. All right, next slide. So let's start practicing already. So this is example 1. It says translate rectangle ABCD 1 unit to the left and 6 units down. So if you don't have graph paper, it's going to be tricky, I'm not going to lie. But what you could do is draw your own graph, number them, 1, 2, 3, 4, 5, maybe go up to 10. negative 1, negative 2, go all the way to negative 10, go all the way to 10, negative 10 here. And draw this image in there where it should go based off where you put your numbers, and then just try to eyeball it or draw in your own grid. Alright, so it's up to you how you want to do it. If I were you, I would draw my own grid so I can make sure that I'm doing it correctly. Alright, maybe draw your grid in pencil. Don't do it in pen because you're going to be erasing a lot. It's up to you if you do not have graph paper. But you do need to write this example down so that you know what to do. Okay. Alright, so I have coordinate A, B, C, D. What I'm going to want to do is write down these coordinates. So this is negative 9, 6. B is negative 3, 6. C is negative 9, 2. And D is negative 3, 2. Actually, after this slide, I'll show you a trick that you could do without even having to make a grid, a coordinate plane. But as long as you show your work, I'll accept it. So I'll show you after we go over this example. Alright, so for this rectangle, I need to translate it 1 to the left and 6 units down. So for each vertice, 1 to the left and 6 down. 1, 2, 3, 4, 5, 6. If you are using a coordinate plane, if you have graph paper or you make your own coordinate plane, I do want to see these jumps. That is your work. That's the work you show me. And remember, this turn gets a new name, so now it's A prime. And that point is negative 10, 0. I keep going. Here's B, 1 to the left and 6 down. 1, 2, 3, 4, 5, 6. Then it turns into B prime. That's the new name after I do my transformation. So I moved it. So it's negative 4, 0. C prime, 1 to the left. Uh-oh, looks like I'm going to overlap. If I want, I can go the other way. 1, 2, 3, 4, 5, 6. It does not matter. So now that's C prime, and that's negative 10, negative 4. And D, 1 to the left, down 6. 1, 2, 3, 4, 5, 6. And that's D prime. When you're doing your jumps, do it lightly. I can't do lightly on this board. It's all the same size for my pen. I can't make it skinnier or thicker. It's the same thickness the whole time. So do your jumps lightly so that when you draw your lines to connect the dots, it's clear, right, and darker than the jumps. Make it that way, darker than the jumps and clear, so you can I can clearly see that shape. Alright, so my last one was D prime, and that was negative 4, negative 4. So that is my new translated image. Alright, so I labeled them correctly. They're all primed. So A prime, B prime, D prime, C prime. And all we did was slide the pre-image. This is my pre-image. All we did was slide this pre-image 1 to the left and 6 down. And that's all the work you need to do. We just translated an image. Now let me show you a trick you can use. I wasn't going to show you this until later on, but knowing that it would be difficult for most of us to get graph paper right now if you don't have it, and it will be hard to create a coordinate plane. Let me show you a trick. Alright, so if I'm looking at this one, I'm just going to use this space right here to show some work. I have negative 9 and 6. Negative 9 is over here, but it says I need to move it to the left. If I am moving to the left or if I go down, that's negative. If I go up or to the right, that's positive. So all I'm going to do is think about if I go one left on the number line, where is that going to take me? Negative 10, which matches that negative 10. So you can think of it like this, negative 9 minus 1, so I'm going to the left, that makes negative 10. Now for the 6, all right, I need to go, that's my y values, that's up and down. It says I'm going to go 6 down. So I'm going to minus 6 because I'm going 6 down. Down is negative, and that makes 0. So that is identical to that. So if you want to use this method to help you so that you don't have to draw the coordinate plane, that's fine. Just make sure you show me your work. Let me do one more. Negative 3 and 6. I need to go to the left one, so I'm going to say negative 3 minus 1. That makes negative 4. For 6, I'm going to go 6 down, so it's going to be 6 down, and that makes 0. And so that's why it is at negative 4, 0, which matches that one. So again, you can use this method to show your work, or if you are using a coordinate plane, make sure you show me your jumps to show your work. All right, next slide. So here's our image right here. I'm going to write down these coordinates. So A is at negative 3, 7. I is at 3, 7. M is at 3, 2. And S is at negative 3, 2. So I'm going to translate this rectangle Ames 2 units to the left and 5 units down. So I'm going to start with A. 1, 2 to the left and 5 down. 1, 2, 3, 4, 5. Do you remember what the new name is going to be? The original was A. What will this one be called? Hopefully you said A prime. And that coordinate is negative 5, 2. Do the same thing for S. 2 to the left and 5 down. 1, 2, 3, 4, 5. And that one would be called S prime. 2 to the left. 1, 2, 3, 4, 5. 5 down. And that's I prime. That's okay that it's over the original image. That's okay. There's nothing wrong with that. Now M. 1, 2, 1, 2, 3, 4, 5. M prime. Now connect your dots. There we go. There's our image. All right, I forgot to write these down. So I prime will be 1, 2. M prime will be 2, negative 3. And S prime will be negative 5, negative 3. Let me show you the work for if you wanted to do the math work. In case you don't have the graph paper. If you have a graph paper and you choose to do the math work, that's okay. I'm fine with that. All right, so let's start off with A. It's negative 3, 7. I'm going to the left 2, so I'm going to minus 2. And for 7, I'm going down, so I'm going to minus 5. This makes negative 5, and this makes positive 2, so that's my new coordinate. A prime equals negative 5, 2. B prime, oops, sorry, not B prime. B, oh, I. I'm thinking A, B, C. The next coordinate is I. So I is 3, 7. So I'm going to put 3 for this 3, and then it's minus 2, and I'm going to have 7 for that 7, and I'm going to minus 5. So then I get 1, 2. So I prime equals 1, 2. Yep, makes sense. That's what I got. M is 3, 2. So I'm going to do 3 minus 2, and then 2 minus 5. And I get 1. Alright, and I get 1, and I get negative 3. Oh, and I realized I made a little mistake right here. Hopefully you caught it. I guess I couldn't really see with all my jumps. So that goes to show to make sure you are doing your jumps lightly. Otherwise, you may get confused with your work, just like what I did. My jumps are the same thickness as the thickness of my line around my image, the edges. So you might make sure that you do it lightly. So it turns into m prime is equal to 1, negative 3. And s is negative 5, negative 3. So it's negative 5 minus 2 and negative 3 minus 5. Oh, I just made a mistake. I put down the, I put negative 5, negative 3 from there. That's not my s coordinate. That's my s prime coordinate that I already did. So s is, s is negative 3, 2. So negative 3 minus 2. And then 2 minus 5. That makes negative 5 and negative 3. So s prime equals 5, negative 5, negative 3. There we go. So I just showed you right here how to do the math work if you do not want to graph it or if you can't graph it. So you have options. Next slide. All right, translation number 3. Translate triangle ABC 12 units to the right and 7 units down. Oh, wow. All right, so let me write down the vertices here. This is negative 9, 7. B is negative 3, 2. And C is negative 9, 2. All right, let's start. If you want, pause this and go ahead and get started. Whether you're doing jumps on a coordinate plane or if you want to do the math work, go ahead and pause this when I'm done talking so that you can practice it. Go ahead and pause. So let's get started. I have A right here. I need to go 12 to the right and 7 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 7 down. 1, 2, 3, 4, 5, 6, 7. And this turns into A prime here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. And that is B prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then down 7. 1, 2, 3, 4, 5, 6, 7. And that is C prime. So let me draw my triangle. Alright, so there's my image. A prime is 3, 0. B prime is 9, negative 5. C prime is 3, negative 5. And you're done. Now let's check our math work. So I have negative 9, 7 as A. I'm going to show my work, negative 9. It says 12 to the right, so I'm going to add 12. When I go up or to the right, I'm going to add. But if I go left or down, I'm going to subtract. So then I'm going to do 7, and then I'm going to go down, so I'm going to subtract 7. So for here, I get 3, 0. So A prime equals 3, 0. Let's look at B. I'm running out of room here. B is negative 3, 2. So I'm going to do negative 3 plus 12 and 2 minus 7. And keep in mind, this is my x value because I'm going left or right on my x value, and this represents my y values. So then this turns into 9, negative 5. So b prime equals 9, negative 5. Let's look at c prime. So c, the original coordinate, is negative 9, 2. I'm going to do negative 9 plus 12, and then 2 minus 7. Negative 9 plus 12 is 3, and 2 minus 7 is negative 5. So c prime equals 3, negative 5. And they match. So you have an option of using this math work or showing your math work using a coordinate plane. You have to pick one. All right, next slide. All right, mind break. Reflections. So this is the second transformation we are going to learn today. The first transformation was translation. Now we're going to be looking at reflections. A reflection is also called a flip. A flip takes place when a shape is flipped across a line and faces the opposite direction. Because the shape ends up facing the opposite direction, it appears to be reflected, like in a mirror. That's why it's called reflection. A shape can reflect across an axis, or which is the y-axis, or the x-axis, or a random line that I give you. But we're just going to focus on the y or x-axis for now. When you're doing this, think about how far away each point is. So think about how far away each point on your shape is from the axis that you're reflecting. So think of the mirror, and I'll show you. Next slide. So right here it says the same thing. Think about how far away each point on your shape is from the axis that you're reflecting. So I will say reflect this image across the x-axis. Or I may say reflect this image across the y-axis. Next slide. So I'm going to start off with this example using the coordinate plane, and then for those who do not have a coordinate plane or grid paper, and or if you rather use some math for it, or the trick that I can show you, you can do that. So just wait until the end, but I want you to definitely see how it works on a coordinate plane. So it says if triangle Kim is reflected over the y-axis, what would it look like? Well, here's my y-axis, and if I'm going to reflect it, I got to think about this. It's like a mirror. I'm not going to slide this over and say, oh, KMI. That's not how it works. If M is over here, when I reflect it, it needs to be over here. And if I is here and I reflect it, I need to be right here. So it needs to be a reflection. So let me erase this. It is not a slide. A slide, like going up and down, or here, if I just slide it over, that is a translation. A translation, you don't have to go up or down. You can just go up or down, or you can just go to the right or to the left. All right, we were doing it twice in the other examples just for practice. So for K-I-M, here's K, here's I, and here's M. K is negative 7, 6. I is negative 3, 2. M is negative 7, 2. So for my reflection, when I was talking about, think about how far away that point is from the axis you are reflecting across. Count. What's the distance from here to here? Well, you can count 1, 2, 3, 4, 5, 6, 7, or you can look from here to here. It's 7. So you're going to go that same distance away on this side. 1, 2, 3, 4, 5, 6, 7. And now it is K prime. Same thing for the M. Oh, it's 7 away. 1, 2, 3, 4, 5, 6, 7 to the line that I'm reflecting across. So I'm going to go 7 that way. 1, 2, 3, 4, 5, 6, 7 to the right. And that is M prime. With I, it's 1, 2, 3 away. So 1, 2, 3 right there. And that will be I prime. Now I can connect the dots, and there is my reflection. It should be the same exact image. The image did not get bigger or smaller. It should be the same exact size. Sorry, that was a school bell. Even though down here on the computer it says 4:08, class is not over. We still have about 20 more minutes. Alright, so K prime is 7, 6. I prime is 3, 2. And M prime is 7, 2. And then you're done. Now let me show you this trick. All right, there's a pattern. What I want you to do is, maybe you can figure it out yourself. Look at these coordinates and compare it to these coordinates. And this only works with reflections, not translations, just reflections. Think about it. What changes? So, I'm going to write this down. This is a good idea to write down. When reflecting across the y-axis, keep the y values the same, but change the sign of the x values. You can see that here. Look, I was at K, negative 7, 6. It's saying if I'm going to reflect it across the y-axis, keep the y value the same, but change the sign of the x value. So instead of it being negative 7, it will be positive 7, just like that one. Let's look at I. I'm going to keep it 2. And then this was negative 3, so I'm going to make it positive 3. For M, keep the y value, which is 2, and then change it from a negative to a positive. And there you go. That's a trick for reflections. So if you want to use this method instead, how can you show me your work? What can you do? Well, you can just tell me on the side, change sign of x values. So you can think of it as the opposite, like this. If you're reflecting across the y, you're changing the sign of the x. And it's the same thing when you are reflecting, well, it's similar to when you're reflecting across the x-axis, right? You're going to change the sign of the y for that example. So let's go ahead and keep moving and see what happens. Next slide. Now here's an example of us flipping over the x-axis. But first I'm going to show you using the coordinate plane, and then we'll use that trick. So J, the coordinate is 3, 6. So it's saying triangle J needs to be reflected across the x-axis. So A is 7, 1. Y is 3, 1. So I need to reflect it across the x. Here's the x-axis. So it's 1, 2, 3, 4, 5, 6 points away. Well, the distance is 6 units away. So it needs to be 6 units away down here. 1, 2, 3, 4, 5, 6. So why are we going up and down instead of side to side? Well, the last example, we wanted you to reflect across the y-axis. Here, we want you to reflect across the x-axis. As it says right here, reflect over the x-axis. So this will be J prime, and that is at 3, -6. Now let's look at y. It's 1 away. So 1 away down here, y prime. So there's my coordinate, and that's 3, -1. And A is 1 away also, so down 1. Now be A prime, and there we go. Here we go. And it's a reflection. This point is right here. When I reflect it to go across, it should be over here. It needs to be the same distance away. So that coordinate for A prime will be 7, -1. Now let's look at this trick. These are my values here. So let's write it down. When reflecting across the x-axis, keep the x values the same, but change the sign of the y values. Oops, that should just be a period. So let's look here. I'm reflecting across the x-axis, so I'm going to keep my x's identical. This is 3, so J prime is 3. This is 7, A prime is 7. This is 3, Y prime is 3. So keep the x values the same, but change the sign of the y values. This was 6, now it should be -6. Yep, this was 1, now it should be -1. This is 1, this is -1. So you can say change, for your work, change signs of y values. So that's enough for me to show me what you were doing, like how you got from here to here. That explains to me what you did. All right, next slide. So go ahead and pause this screen and go ahead and do this one on your own so you can have practice. And then come back. All right, so R, the coordinate is negative 8, 3. For E, it is negative 3, 3. For D, it is negative 8, negative 2. For S, negative 3, negative 2. Now if I wanted to use my trick, I'm reflecting across the X. So I'm going to keep the X the same, but change the sign of the Y. So let's keep our X's the same, but change the signs of the Y. So this was 3, now it should be negative 3. This was 3, now it should be negative 3 after we do our reflection. This is negative 2, then it should be positive 2, because I got to change the sign. It's negative, so change it to positive. I had negative 2, I'll change it to positive 2. It's doing the opposite. We're doing the opposite. When we're changing the sign, we're doing the opposite because it should be on the opposite side of the axis when you're reflecting. It should be on the opposite side of the line, whatever line you're reflecting across. So for my work, I would say change signs of Y values. And that's enough work for me. That's okay, because what else are you going to do? You're not really adding or subtracting anything, so that's enough work for me. But let's verify these answers to make sure it makes sense if I were to actually do the reflection. So E is 1, 2, 3 away, so 1, 2, 3. That's E prime, and that's at 3, 3. I just realized that I was reflecting across the wrong axis when I moved over here. So I got to reflect across the X. Forgot about that, sorry. Alright, so for E it's 1, 2, 3. So then 1, 2, 3, this will be E prime. And that makes, so I'm going to write it over here. E prime equals negative 3, negative 3. Now S, it is for S, it's 2 away from the axis. So I'm going to go 2 away over here. So it's going to be, this is S prime. So S prime equals negative 3, 2. Whoa, it kind of looks like it's going the other way. That's okay, because look, this shape is already over the x-axis. If I'm reflecting it, it's just going to go the other way, and it's going to go over it, so that's okay. So R, it's 1, 2, 3. So 1, 2, 3. R prime, and that is at negative 6, negative, negative 8. Negative 6 is here. Negative 8, negative 3, and that's R prime. And then D, 1, 2, so it'll be 1, 2, that's D prime, and that is negative 8, 2. So it makes sense. There we go, like this. There we go. And again, it looks kind of funky because it's on top of its original image. That's okay. All right. Next slide. So, in summation for this trick or this pattern, when reflecting across the y-axis, keep the same y values and change the sign of the x values. So think of the opposite. Okay. When reflecting across the x-axis, keep the same x values and change the sign of the y values. Think of the opposite. So for translations and reflections, you have two options. Either do the jumps and do the work on a coordinate plane if you want to, and or if you have graph paper. You can make your own coordinate plane that works as long as it's clear and easy for you to use and easy for us to see your work. Feel free to use that. If not, use the tricks that we showed you. All right, next slide. All right, that's the end.